So it's a pleasure for me to be here to give you a kind of general talk on some work I do which has to do with cell vibration. And I'm in the chemistry department at UCLA and also in the California Nanosystems Institute. So this is something, when you think of chemistry, you perhaps think of atoms, solid, materialistic types of things. But in many ways, you can think of chemistry to be actually vibrations. And in quantum mechanics, Erwin Schrödinger, who actually is one of the people who described quantum mechanics in a very reasonable way, he actually used musical theories. Could I have the next one? So, in a sense, if you consider an atom is mainly actually nothing. There's nothing there. But it can be considered to be a type of wave-like, wave-like existence. And on the left, what you see are the fundamental modes of a normal string, like a guitar. And if you play guitar, you know how you can play harmonics. So these would be the fundamental. The first one, the second one is a harmonic. And de Broglie, who actually described the quantization of atom, he actually just used this type of theory here, but you imagine now that the string is a circle. That would be the electron in some orbit, and you can fit in a certain number of waves perfectly into a circle. And so therefore you have the different modes of vibration, if you like, of the electron in the atom, and that perfectly explains the quantum mechanics of atoms. Now, if you take something like biosciences, it's also treated in a very materialistic way. You are treated in a very materialistic way in the sense that everything has to do with your DNA, which is just a kind of sequence of 4 letters that repeat themselves and give you your supposed characteristics. And most of the things you eat today, that sequence has been modified in some way, genetically modified foods you eat. But there's also another way you can think about life, and that is, this was from Nature, which is a quite famous journal. You can also think of life to be a very dynamical phenomena. So at this moment in your body, every cell is actually full of little molecular machines that are moving back and forward. And this is something that I became very interested in nanoscience. And the way we started this work was actually to look at yeast. Yeast is, you find it in beer, you find it in bread. And we started to study the actual motion of yeast cells. And this is the paper Maurice is talking about. It was published in Science a few years ago. And we use a thing called an atomic force microscope, which is actually a type of finger, but it's on the nanoscale. So a yeast cell is about something like 1/20th the diameter of your hair. And if we use a very sharp tip, we can record the motion of the yeast cell, somewhat like you would record in the old days, if you remember, gramophone records, okay? You can pick up the motion of the music and the grooves. So we don't need to move this thing, but we just follow the motion of the yeast cell. And what we discovered was something kind of very strange. That is, on the scale of a nanometer, and I mean, it would be like 10 atomic diameters, very, very, very small, we found a distinct oscillation. And this is a plot of that oscillation recorded on, on the nanoscale. And the time scale here is such that it puts that motion of the yeast cell into the audible range. Now, it's actually an inaudible phenomena normally because the motion's so small. But what we did was we did not change the tone, but we just pumped up the volume. And this is 22 degrees centigrade, room temperature. This is how yeast sounds, so maybe a bit loud, okay. I like it loud. That's good. Okay. And so yeast cells something collectively is moving inside them that causes this motion, this type of motion. Now, when we change the temperature just by a little bit to make it warmer, you can see the pitch increases. And if you heat it up even more, it's more active. Now you hear a much higher pitch. So the pitch depends on the temperature, and we actually used that information to work out what type of machinery was going on inside that cell that caused the motion. And our conclusion was that it's these small molecular motors called myosin that are moving, but individually one is not sufficient to cause a massive effect. And the type of effect we saw actually relies on the fact that all of these molecular motors somehow are working together. And so there is a kind of, it's like an orchestra. Somehow inside that yeast cell, they all work together. This one, could you play, this is dead. This is a yeast cell in which we actually deactivated the molecular motors. They're not, it's not dead in a kind of sense, it's dried up. Could you just play dead? There's dead. And what you hear there is a hiss, and that hiss is actually just the background energy of the room, okay? It's on a much smaller scale. And we did some things, that was the Nature paper, we put some alcohol in it, that was one of the, to stress it out, and that is a stressed yeast cell. So that was good fun to do that research. However, there were some animal rights or right to life people who said that we were actually murdering the cell. Honestly, I'm not kidding. Okay, so this is this on the right here are these myosin motors, and they kind of walk across actin filaments, and they somehow are all working together. And you know, if you look at many theories about healing and vibrations and the Hindu religion and so on, Tibetan monks, you'll find that sound is a very, very important part of you know, therapy and meditation. And indeed, after this work, I was contacted by the Maharishi Yogi, who wanted a copy of the paper, and also by many people in traditional Chinese medicine, because in Chinese medicine, the highest form of medicine or diagnosis is actually sound. Okay, so from there, after that paper was published, there was a popular paper, sorry, not popular paper, but a magazine called the Smithsonian magazine. They did an article on the yeast cells. And one day the phone rang, and I don't usually answer the phone. I have an assistant to answer the phone. But I picked up the phone for some reason, and there was a lady, her name was Anna Costello, and she actually collects the sounds of different insects, you know, like flies, bzz, buzzing and so on. And she said to me, you know, is it possible to hear the sound of metamorphosis? And I thought, oh, we've got a nut here. But she turned out not to be a nut. But she said she wanted to hear the sound of when a pupa, you know, the caterpillar becomes a pupa, and then the pupa, over a period of a week, generates a butterfly. There's a massive cellular transformation. Could I hear that? And I said, wow, that sounds crazy. I'll listen. I'll try to do it. And she had a friend, Richard Stringer, who has a butterfly farm in Florida, and he sent me some pupa. And this is actually, this one here is the monarch butterfly. We started with a painted lady. And what we did was we attached, where you see that little dot, a tiny, tiny mirror on it, and then we looked at how a laser would move back and forward to record actually the motion of the pupa. And this is what we saw. The next slide, please. Well, first we saw that it was changing color, and eventually this came out. But when we actually followed this for a whole week, we saw that there were bursts of periodic oscillations. And what happened was that this thing, as it undergoes the metamorphosis, is actually it's not continuously changing. It's undergoing bursts of oscillation. And then there's a period of quietness and another burst. And towards the end of the cycle where it emerges, the activity increases so that the on period is much longer than the virtual off period. And this shows some of the characteristics over hours. Like the one on the right is towards the end, and the one on the left is at the beginning. And so we decided, well, you know, I work also, as well as in science, I also work in art. I do a lot of work in art science with an artist. Her name's Victoria Vesna, who's in the audience, and she was the director of Media Arts, and now she is she's actually director of research at Parsons New School in New York, and also the director of our art science program, which we have at UCLA. And so, rather than publish this data scientifically, I thought this would be a very interesting piece. After a long while, we decided to do something with it, and in the process, Richard sent me the butterfly man sent me some blue morpho butterflies. These are butterflies that have iridescent blue wings, and if you look into those wings, this beautiful metallic color, they have no color, they're black. And what nature has done is structured the wing in a periodic way on the nanoscale such that when you shine light on it, it generates that blue color. And so we combined that, and we can show this now, we combined that with the imagery of this butterfly wing taken with an electron microscope with sound. And Gil Kuno, who is a quite well-known Japanese artist, also contributed on this. And what you hear here is the sound of metamorphosis. In this case, we speeded it up. The frequency is really about ½ a hertz. But what you can hear is this agonizingly painful sound of the cellular transformation. And it turns out that when the butterfly, when it emerges, it's very different cellularly from when it started, obviously, as the caterpillar. But something remains. We did MRI imaging of this butterfly at very high magnetic field. Hard to do MRI imaging on something this size, but we did it. And what we found is that there are 8 interconnected pumps, and they actually very much resemble to me chakras. And those pumps don't change. And so that motion you see are the pumps operating. And so to conserve energy through the process of metamorphosis, the butterfly, or the pupa, it just switches on the pump when it has to do some cellular transformation during the week. So this piece here, we actually generated into a kind of installation. And the installation was originally for fun. And we had it at the Integratron, which is a dome. It's a dome out in the Mojave Desert. And we had some blue lights, and we had an area where people could think about change, think about changing their own lives. And they would sit in the center and be surrounded by other people. And it was meant as a light-hearted piece. But it turned out the piece should have ran, I think, from 7 o'clock to 9:30. It actually went on until 2 o'clock in the morning because the people just meditated, and we couldn't get them off. And they took it so seriously. Then we ran it a second time, also in the Integratron. We were sold out. People came from everywhere. Even one came from New Zealand. And they were queuing up outside. And one guy was really angry. He said, I should have, it should have started now, and so on. And Victoria said to him, well, you can have your money back. And he goes, "Rrr." He sat down on that piece and meditated and listened to those sounds. And he was transformed. He was so happy. It was the best moment in his life. So what's really strange is, and I still don't understand it, what is going on with the sound and the meditation and this type of process. So what we do at the moment is try to study human cells. And that has been a piece of ongoing work where we worked with the UCLA Medical School, mainly studying how soft cells are, because it's very hard to pick up motion, but there is motion, to differentiate cancerous cells from non-cancerous cells. And I believe that in the scientific world we live in at the moment, there's always this desire to think in a very reductionist way. But when we work in nanoscience, it's actually something that inspires one to think a bit in a broader way. So the concept of just pure materialism, you know, DNA, pure materialism, thinking of atoms of gold, is perhaps something that people could do with a kind of alternative view to the world, an alternative view. And if you look at atomic atoms, even from the point of view of fundamental particle physics, what explains it is string theory. And string theory is vibrations. There are vibrating strings made out. There is no matter at the very, the very highest levels of physical theory. And I think as we look perhaps at people and human beings and illnesses, maybe in the end we'll find that the traditional Chinese medicine people are actually maybe more in tune with the world than we are. We're a materialistic world. So with that, I'd like to thank you all.